morning children. In today's class, we are going to learn about probability. Probable. Most of us use this word. Most probably, it may rain tomorrow. Most probably, it may be a holiday. Most probably, my uncle would come home. So, the word most probably, probable, tells about chance. Chance of something to happen. Probability is an easy and interesting concept that we often use in our day-to-day life also. Whenever I say this word probability, many of us recall tossing a coin, throwing a die, selecting a card from a pack of cards. So like this, you can say many of the experiments in day-to-day life. Yes, these are called random experiments. What do you mean by the word random? See, supposing I am going to question you. Do any of you know whom I am going to exactly question? No. The children who are gathered here, 1 to 60. I may call out any of your name. Everybody will expect my name would be called out. Yes. We know 1 out of the 60 will be called. But not exactly who is going to be called. Such an experiment we call random experiment. The outcomes are not predictable. When I toss the coin, no one knows whether head would turn or tail. When I throw a die, nobody can exactly say which number would turn out. But we all know from 1 to 6, any of the face will turn. So this idea we call random experiment. When I throw a die, we are sure 1 to 6, any of the numbers will turn. That 1 to 6, what all is sure to come as one of the answers. I call sample space. Once I know sample space, I may come and say, I want an even number. You can claim, I want a multiple of 3. So anybody can claim anything from this 1 to 6. That what we claim is called event. So event is a subset of sample space. Once I know sample space, event and random experiment. About events, what all can I say? Suppose head comes when I toss. Can tail come? No. Suppose tail comes. Can head come? No. Such events we call mutually exclusive. A comes, B cannot come. B comes, A cannot come. A and B exclude each other. Such an event we call mutually exclusive. Not only 2, there are many also. Whenever they are mutually exclusive, I can remember union is replaced as addition. Now another idea. Supposing you go to beach where you have numerous events like balloon shooting. 3 or more can try the balloons. One person hits it or not doesn't relate to the other person. So 2 persons are hitting. Either A can hit or B can hit or both can hit. This does not depend on the other. Such events like shooting a target we call independent events. In today's class, mathematically how we are going to approach these events, let us discuss. An experiment is a process in which the result is well defined. When I say random experiment, we know all possible outcomes, but exactly which outcome will turn out in a trial we do not know. Sample space is a set of all possible outcomes of a random experiment. Event, if I claim I want a head while tossing a coin, so event is getting a head. So every event I would call a subset of a sample space. Sure event, the full sample space, yes, we declare it is sure to happen. So that is a sure event, and we know the probability of the sure event is 1. When I toss a coin, suppose I claim I want number 25. Can it happen? No. If I toss, I can claim a head or a tail. If I claim something that cannot happen, we call impossible event, termed as phi, and probability of an impossible event is 0. Something that is possible will be in between 0 and 1. So we define the probability of an event will be between 0 and 1. Probability cannot be negative. Suppose I know the event A. If I want not A happens is A. A does not happen I term as A bar, call it as complementary event. And P of A bar is 1 minus P of A, because getting A and not getting A together, the probability is 1, because we know the maximum probability is sure event, which is 1. So P of A bar will be 1 minus P of A. In events, we have many types. An important type I would call mutually exclusive events. If I toss a coin, I will say, getting a head will prevent getting the tail. Getting a tail will prevent getting the head. So if an event A prevents B, I will call A and B are mutually exclusive events. For head and tail, there is nothing in common. So we say A intersection B is phi in case of mutually exclusive events. Probability of phi, we already said 0. So P of A intersection B is 0. P of A union B in case of mutually exclusive events. Union is replaced as addition. Let us remember, in mutually exclusive events, union is replaced by addition. So P of A union B is P of A plus P of B. And now we have the next set, say equally likely events. Suppose there are 50 children sitting in front of me whom I am going to question. Every child's probability of being asked is 1 by 50. So every child we say equally likely event. Everyone has the same chance of being asked. So probability of A, as we define, it is n of A by n of S. Number of favorable outcomes by total number of exhaustive cases. Axioms of probability, to recall, we say probability of A is always positive, greater than or equal to 0. And we know the total probability is 1. So probability of any event lies between 0 and 1. And in case of mutually exclusive events, union is replaced by addition. This is also an axiom of probability. The next important concept that we learn often in probability or statistics is odds. Odds relate the chances in favor of an event A to the chances against it. Suppose A represents the number of ways that an event can occur, and B represents the number of ways that an event can fail to occur. A, the possibility to occur, and B, the possibilities to fail. Then the odds of an event A are, A is to be in favor of an event I call A by A plus B. Odds against A we call B by A plus B. Let us remember, A, an event can occur. B, an event fails to occur. Then odds of an event A in favor of an event is A by A plus B, and odds against A we call B by A plus B. Let us proceed into exercise to understand better. Exercise 12.1, question number 1. An experiment has the 4 possible mutually exclusive and exhaustive outcomes A, B, C and D. Check whether the following assignments of probability are permissible. Given P of A, P of B, P of C, P of D. Let us check whether P of A is greater than or equal to 0. So this is the first condition for the probability to be permissible. Check P of A, P of B, P of C, P of D. All are positive. So every probability is between 0 and 1. So the first condition is satisfied. Proceeding to the second. Find the total probability. If the total probability is 1, we declare the assignments are permissible. Checking here, 0.15, 0.30, 0.43, 0.12. As I add them all, I get 1.00. Total probability is 1, so the assignments are permissible. Second subdivision, as I look out, each probability is between 0 and 1. Second condition, find the total probability. My answer is 1.10. Total probability is not equal to 1. So we say these assignments are not permissible. Subsection 3, as we look out, P of C is negative. The very first condition is probability should be positive. It should be between 0 and 1. So here minus 1 by 5 is not admissible. So we will immediately say these assignments are not permissible. Question number 2. If 2 coins are tossed simultaneously, then find the probability of getting 1 head and 1 tail. Second subdivision, at most 2 tails. As I read the question, 2 coins are tossed. Immediately I will write the sample space. Both can be heads or head first, tail second, tail first, head second, or both can be tails also. N of S should be a coin has 2 faces and 2 times it is tossed. So 2 power 2, it should be 4. So we have the 4 different outcomes. Now the question is, I want a head and a tail. Where you have head and a tail, HT, TH. You have 1 head, 1 tail. So my answer would be HT or TH. There are 2 possible outcomes. N of A is 2. P of A is N of A by N of S. That is 2 divided by 4. So we get 1 by 2 as the answer. Subdivision 2. At most 2 tails. At most, the word tells me 2 or below. So it can be 2 tails or 1 tail or 0 tails. Where do you have 0 tails out of the 4 outcomes? HH. No tails at all. 1 tail, I have HT, TH. And 2 tails, I have TT. My question is 0 tails or 1 tail or 2 tails. So adding all the answers. 1, 2, 3, 4. So my answer is 4 out of 4. That is 1. So at most 2 tails tells me 4 out of 4. That is 1. So all these put together, I get N of A is 1, 2, 3, 4. So my answer is N of A by N of S. That is 4 by 4, which is 1. Question number 3. 5 mangoes and 4 apples are in a box. As I read the question, let me write 5 M and 4 A. M stands for mango and A stands for apple. If 2 fruits are chosen, Altogether, there are 9 fruits. 5 plus 4, we get 9 fruits. From 9 fruits, we are choosing 2. What is the condition? N of S is out of 9. I am choosing 2. So it is 9C2. My answer 9 into 8 by 1 into 2, or I will say it is 36. Now my question is, one is a mango and the other is an apple. There are 5 mangoes from which I want 1. The number of ways is 5C1. Now 1 apple. There are 4 apples from which I want 1. Number of possible ways is 4C1. I want 1 mango and 1 apple. So let me multiply. This is N of A divided by N of S is 36. Or I get 5C1 is 5. 4C1 is 4 divided by 36. As we simplify, our answer will be 5 by 9. Now the second subdivision, both are of same variety. Same tells me both can be mangoes or both can be apples. How many mangoes are there? 5. From 5, I want 2 mangoes. Or from 4 apples, I want 2 apples. So when I say and, I multiply. When I say or, I add it. And the denominator, remember to write N of S. It is divided by 36. The probability we write N of A by N of S. N of S is 36. N of A. 2 mangoes from 5, 5C2, or I just add 2 apples from 4, it is 4C2. How am I to simplify? 5C2 is 5 into 4 by 1 into 2 plus 4C2 is 4 into 3 by 1 into 2 divided by 36. As we cancel and we simplify, we get 10 plus 6 divided by 36. 16 by 36, or I get 4 by 9, and that is the condition for both to be same variety. Question number 4. What is the chance that non-leap year, second subdivision, leap year should have 53 Sundays? Non-leap year will have 365 days, which can be rewritten as 52 weeks plus 1 day left. 365 if I divide by 7, because a week consists of 7 days. I divide by 7, I get 52 full weeks and 1 day left. What that 1 day could be? It could be Sunday or Monday or Tuesday, etc. up to Saturday. So the 1 day chance, we have 7 ways. So N of S is 7. My question is to have a Sunday. Out of the 7 chances, Sunday has only 1 option. So N of A is 1. So P of A we call N of A by N of S, that is 1 by 7. The second subdivision is leap year. Non-leap year has 365 days, whereas leap year has 366 days. As I divide by 7, I get 52 full weeks and 2 days are left. The 2 days, how the combination could be? Consecutive days. Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or Saturday, Sunday. How many such combinations are there? 1, 2, 3, 4, 5, 6, 7. So N of S is 7. Again, my question is 53 Sundays. So the extra 2 days, Check where you get a Sunday combination. I have Sunday, Monday one way or Saturday, Sunday another way. So in two combinations, I have Sunday. So what are the two combinations? I have Sunday, Monday combination or Saturday, Sunday combination. So there are two such cases. N of A is 2. What is P of A? N of A by N of S. It is 2 divided by 7. Question number 5. 8 coins are tossed once. Find the probability of getting exactly 2 tails, at least 2 tails, at most 2 tails. How many coins are tossed? 8. Each coin has 2 faces. Head, tail. So when I say 8 coins are tossed, what would be N of S? It will be 2 to the power 8. That is 2 into 2 into 2. Up to 8 times I multiply. My answer is 256. Subdivision 1. Exactly 2 tails. 8 coins have 8 tails. But my question is only 2 tails. So what is N of A? Out of 8, I want only 2. It is 8C2. How do I get it? 8 into 7 by 1 into 2. As we cancel, I get 28. So what is P of A? N of A by N of S. It is 28 divided by 256. As we cancel with 4 table, it is 7 by 64. Second subdivision, at least 2 tails. The word at least tells me 2 or more. 2 or more. So it could be 2 tails, 3 tails, 4 tails, 5 tails, up to 8 coins are tossed. So I will get up to 8 tails. Getting from 2 to 8 would be a difficult process. So what shall we do? Whenever the process is difficult, you go with what I don't want. What I want is 2 tails to 8 tails. So what I don't want is 0 tails or 1 tail. Find this probability and subtract from 1 because the total probability is 1. So remember, in probability, what I want is difficult. How do you get it? 1 minus what I don't want. So it is 1 minus 0 tails. How do I write it? There are 8 tails. I want 0 tails. Or, so we add it. There are 8 tails. I need 1 tail. The whole thing divided by N of S is 256. As I simplify, it is 1 minus 8C0. Whenever 0 comes, the combination result is 1 plus 8C1 is 8 divided by 256. Taking LCM, 256. 1 into 256 minus 1 plus 8 is 9. Or I get 247 divided by 256. Subdivision 3. P of at most 2 tails. The word at most tells me 2 or below. So it could be 2 tails or below 1 tail or 0 tails. 0 tails, I will write 8C0. 1 tail is 8C1 and 2 tails is 8C2. The whole thing divided by the total probability N of S, 256. As I simplify, 8C01, 8C1 is 8. 8C2 is 8 into 7 by 1 into 2. The whole thing divided by 256. As I simplify, 28 plus 8, 36 plus 1, 37 divided by 256. This is the probability for getting at most 2 tails. Question number 6. An integer is chosen at random from the first 100 positive integers. What is the probability that the integer chosen is prime or multiple of 8? As I read the problem, positive tells me 0 should not be included. So the numbers are 1 to 100. N of s is 100. Why? Because we are choosing an integer. That is, one integer is chosen. So n of s is 100. As we list out A to be the event of getting prime number, what are the prime numbers from 1 to 100? We have listed there are 25 such numbers. It is 25 out of 100. The second condition is a multiple of 8. What are the multiples of 8 from 1 to 100? We have listed and we have 12 such numbers. So P of B is 12 by 100. P of A is 25 by 100. We do not have anything in common. N of A intersection B is 0 and P of A intersection B is also 0, as they are mutually exclusive events. We would say P of A union B is P of A plus P of B. As we add both, we get 37 by 100. So probability of getting a prime or a multiple of 8 is 37 by 100. Question number 7. A bag contains 7 red and 4 black balls. 3 balls are drawn at random. Find the probability that all are red, 1 red and 2 black. Question says a bag contains 7 red and 4 black. We have written 7R and 4B. R for red ball and B for black balls. How many balls altogether? 7 plus 4, 11 balls. How many are chosen? 3. 3 from 11. We have the combination 11C3, which we term as N of S. First subdivision, all are red. How many red balls are there? 7. How many do I want? 3. So 3 red from 7 red, we will say 7C3. So getting all to be red, the probability is N of A by N of S. That is 7C3 by 11C3. 7C3 is 765 by 123 by 11C3. 11, 10, 9 by 123. As we cancel 1, 2, 3 and 1, 2, 3 and simplifying further, we get probability of all the balls to be red is 7 divided by 33. Now the second subdivision is 1 red and 2 black balls. How many red are there? 7. From 7, I want 1. The probability is 7C1. 2 black from 4 black. 2 from 4. I will write 4C2. Together, I want and. So let me multiply. It is 7C1 into 4C2 divided by. The denominator is N of S, that is 11C3. As I simplify, 7C1 is 7 into 4C2. 4 into 3 by 1 into 2 by 11C3. 11, 10, 9 by 1, 2, 3. As we simplify, we get 42 divided by 165. Cancelling with 3 table, we get probability of getting 1 red and 2 black balls is 14 divided by 55, and that is the answer. Question number 8. A single card is drawn from a pack of 52 cards. A card from 52 tells us N of S is 52. What is the probability that the card is an ace or a king? When I say the 52 cards, we should remember there are 4 ace cards, 4 kings, 4 queens, 4 jacks and the numbers from 2 to 10 in all the 4 symbols. The 4 symbols are spade and club in black, heart and diamond in red. Now the question is ace or king. There are 4 ace cards and 4 kings. So getting ace is 4 by 52. Getting kings is 4 by 52. They are mutually exclusive. No card is an ace as well as king. So my answer is just to add the 2 probability. I get 8 by 52. Cancelling 4 table, it is 2 by 13. The second subdivision, the card will be 6 or smaller. 6 and smaller numbers will be 5, 4, 3, 2. We do not have 1 in cards. The numbers from 6 to 2, totally 5 different digits and each digit in 4 symbols. So 5 into 4 cards are there. So 20 out of n of s, that is 52. 20 by 52, cancelling 4 table, we get 5 by 13. Third subdivision, the card is either a queen or 9. A queen, we have 4. So 4 out of 52. 9, we have 9 in the 4 different symbols. So 4 out of 52. Again, no card is a queen as well as 9. So there is no intersection. R can be replaced as addition. My answer is 8 by 52. Cancelling 4 table, we get 2 by 13. Question number 9. A cricket club has 16 members, of whom only 5 can bowl. So the bowlers are 5 out of 16. The remaining people, we can put in some other head, say batsmen. What is the probability that in a team of 11, so I want a team of 11 from 16 members. So what is n of s? 16C11. How do I calculate 16C11? It is 16C, 16 minus 11. We know the formula. NCR is NCN minus R. So 16C11 will be 16C. 16 minus 11 is 5. What is 16C5? 16, 15, 14, 13, 12 by 1 to 5. As we simplify, we get 4,368. So n of s is 4,368. Now, how to choose the team? We have a condition. What is the condition? The team should contain at least 3 bowlers. How many bowlers are there? 5. My question is at least 3. So, 3 or more. So, it could be 3 bowlers or 4 or 5. The remaining batsmen, I have to choose the remaining for the team. The team should contain 11, in which 3 are bowlers. So in 11, 3 are bowlers tells me balance 8 should be from this people. Similarly, when I want 4 bowlers, 11 minus 4 is 7, so 7 should be from this people. When I want 5 bowlers, 11 minus 5 is 6. So 6 should be from this team. So now how to frame the team? From 11 I want 8. How will I write it? 11C8. And so multiply. From 5 I want 3. It is 5C3. The second case. From 11 I want 7. So it is 11C7. And from 5 I want 4. 5C4. Third case. From 11 I want 6. 11C6. And from 5 I want 5. So it is 5C5. Can I choose 6 bowlers? No. Because there are altogether only 5 bowlers. My question is at least 3 bowlers. So it would be 3 or more. So 3, 4, 5 are the only cases. Or, so all these answers As I find, I need to add, because either this way or this way or this way. So whenever I use the word or, I will be adding. Now we know the combination formula. Let us simplify. As we check in the calculation, I get 11C8 can be written as 11C, 11 minus 8, 3. 5C3 can be written as 5C, 5 minus 3 is 2. As we simplify, we get 1650. Second case, as I simplify again, I get 1650. Third case, 11C6 into 5C5. Same number comes, the answer is 1. And as I simplify, I get 462. Add it all and the total we call N of A. So N of A is 3762. What is P of A? N of A by N of S. It is 3762 divided by N of S is 4368. Cancelling by 6 table, we simplify the answer as 627 divided by 728, and that is the answer. Question number 10. The odds that the event A occurs is 5 to 7. Find P of A. When I say the odds that the event A occurs is 5 to 7, P of A would be 5 by 5 plus 7. That is 5 by 12. The second subdivision, suppose P of B is 2 by 5. Express the odds that the event B occurs. First subdivision, they gave occurrence. We had found out P of A. Now the reverse. P of B is given. We need to find the occurrence. So what is P of B? The formula A by A plus B, where A is B occurs and B fails to occur. Now they have given A by A plus B is 2 by 5. As I compare, A is 2 and A plus B 5 tells me B equals 5 minus A, or 5 minus 2, that is 3. Now my question is, express the odds that the event B occurs. How do I write it? Occurs tells me A to B, or I will say A is to B. Here A is 2 and B is 3. Therefore, odds that the event B occurs is A to B. Here A is 2 and B is 3. So I will say 2 to 3, and that is the answer.